Hey, Engraver here. Welcome back to my channel. This video is on iteration, or at least the very basics of iteration. I had a comment back in November. A gentleman had expressed interest in going deep in iteration, and I thought that was a great idea because I just have a vague sense of what iteration does in SuperCollider. And I will disclose that this is not a tutorial. This is more a walkthrough of me learning the ropes. If you do want a tutorial, I highly recommend Eli Fieldsteel's channel. And in fact, I'll include a couple videos where he does focus specifically on iteration, and I think that will help you get a comprehensive understanding of what iteration is in SuperCollider. And so with that, we'll just go ahead and learn this together. Now, iteration in its description requires a receiver, a stream of values or list that is typically passed through a function. This function will determine the output of the list, but the receiver is needed, and it's needed for the methods do and collect. Now, I can't say that these methods, do and collect, are the most common. They're the most common that I have seen, and you can see under here, under iteration, which is actually under the help file of a collection under the superclass of all collections. Do is part of the iteration category, but you can see that going down, we have a lot. So I'm just going to focus on do and collect and what they can do. But you notice with these, there's also a function needed. So it's the same with do and collect. So before I get into the definition of do, let's go ahead and evaluate this using our integer 5. You can see in the post window here that this is our returned receiver. 5 is the integer, and it's returning 5 as the receiver. Now, using this neat little trick here, which we also use for multi-channel expansion, we can create an array of 2. So 2 items in a list, and both are saying it's the integer 5, and as you suspect, we've got a list of 8 with values 5 inside. So to randomly choose a value, we'll just go ahead and select a number between 1 and 10, and we're going to have 10 iterations, so passed through 10 times in order to have an array. So in this case, SuperCollider has an array of 10 values as we had specified here, and it has chosen the number 7. This time 2, 2, 10, 10, 4, and so on. Now, to get different values, random values, we have to pass it through a function, and all we need to do really is use this rrand method and randomly choose values between 1 and 10, and pass it through where we have 10 iterations of that. So let's declare x to this function, and voila, we have randomly selected values between 1 and 10, and it has passed forth through a function, and the result is 10 values. And you can see that we have a few things outputted more than once. And once we have evaluated x, that remains fixed until we otherwise override it. So evaluating x once more and overriding it here, and so on. But do keep in mind that this arrow here is indicating that this is the receiver. It's returning the receiver. So do keep that in mind for the future. Now we can also random it to an even number like so. And we can also make it a float point using our float point there. And once that is evaluated, it is now a modified collection of floating or float numbers. Now for do, it evaluates a function for each item in the collection. The function is passed through 2 arguments, the item and the integer. So let's go ahead and create a block of code that includes an item. So it must include an argument inside this function and a counter. And as you can see here, I have ready to post an array of any value between 1 and 10 and include a counter inside. So what you see here is the item itself going in ascending order from 0 through 6. And I have the counter here going from 0 through 6 in ascending order. So you can see the receiver is a bit different. It's not the result, it's the receiver. That receiver is essentially an integer, and that integer is 7. And this time it's 5, going from values 0 through 4, 5 again, 8, and so on. Now let's go ahead and apply randomness to it, where we have pretty much the same format, but we're adding that beautiful function. All right, so it's a bit jagged here, but you can see that our counter is ascending as normal. And it is 0 through 9, meaning we do have 10 iterations. And so we have 7, 8, 7, 4, 3, and you can see that our receiver was such. Pretty much what you see here is what looks like the array here. So imagine this receiver being here, for instance. That's what the receiver would look like. That's basically what has been outputted here. But let's move on to array and go ahead and just use an array of values 1 through 10 in ascending order. And in this case, I'm going to put the counter ahead and square the item. So we should see a list of arrays, I should say, going in ascending order here from the counter, and each number you can see here is squared. But this is the result passed through a function, and of course with the do method, the receiver is returned. All right, in this case we can use our array class to create a new array for every instance, but not much is changing. So why is the receiver being returned? Why is that so important? Right now it's a bit redundant. We're going to see how it actually affects something like sound synthesis in the future. So it's just another example where I have X declared here and just one counter, and it's just equating that. It's saying this counter really is this item squared. And there we go, down a list, and the receiver, of course, is returned. But in this case with do, we're not storing the results. If you want to return and store a modified collection, you must use the collect method. So we'll be creating a new empty array that holds the new calculation. It's returning a new collection, a new result, instead of the receiver. And this is the difference between do and collect. So I have here a global variable, a, saying a is a list of 1 through 10 and collecting them and squaring them. And watch what happens. A couple things happen. Instantly, you can see that the result is in ascending order, values 1 through 10, but they're not returned as the original receiver. These are in fact squared as the function has commanded. And Fieldsteel actually included this condensed version. I can understand why programmers would want something short, like a shortcut, but if you want that yourself, that's great. I kind of prefer the blocked code here, or block of code, I should say. I just see it better that way, but there you go. Now I'm going to randomly select again a value from 1 to 10 and collect it where it's going to pass through the function, and whatever value that's going to be the resulting array. So if it's 3, it's going to have 3 items, and 1 through 3, I believe, will be squared, or maybe it's going to be 0 through 2, I'm not sure, but we'll see what it is. All right, in this case, the receiver was 1, 2, 3, 4, 5, 6. So we go from the 0th value, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3, 9, 4, 16, and 5, 25. And this is 3, and 6 again, just 1, and all of that. And let's go ahead and randomly select a value and create 10 iterations. Right, we've got a random selection. In this case, 9 was outputted twice, then 10, then 4, then 10, then 1, and so on. And you can see that these are repeated. So there you go there. Okay, to review, do and collect are similar, but with do, you evaluate a function for each item in the collection, and it passes through 2 arguments, the item and the index here. Now with collect, it answers a new collection which consists the results of the function evaluated for each item in the collection. And that's going to be important now for sound synthesis as we turn to sound synthesis. Now I have here in this document a reminder to boot the server, but I already have it booted, and I've got my level meters here and my node tree for seeing the synthesis or the synths there. And I have a sawtooth oscillator here, pretty simple synth def, and actually was inspired by Fieldsteel, especially with this control parameter here. But it's a simple variable duty oscillator, and if we turn it over to here, we've got a few methods. I'm using freak and an amp and an output argument, as well as an envelope, a signal, and also this control setting here. Now with my envelope, just to give you an idea, it is looking a little like this. So any sound that you hear, any of the sawtooth oscillations that you hear will have a general shape going up 1 second and kind of releasing here for about 3 seconds. Now for this additional variable, which I will call freak control, it's a multiple to the frequency argument. And what this is a linear interpolation of 8 instances. And what these instances are just oscillators kind of meandering back and forth between, it's not really detuning, but kind of a slight going up just slightly above 80 hertz and going slightly down. So with that, and using this splay class here, which spreads an array of channels across a stereo field, it will produce a bit richer texture than just the simple oscillator, a sawtooth oscillator. So let's go ahead and evaluate that. This is all from Fieldsteel's video. All right, and we'll go ahead and take a listen. That was kind of nice. We'll just add 100 to it. Pretty smooth. I wouldn't say it's as cool as Fieldsteel's example, but it will get the job done. So now we're going to use MIDI values, converting hertz to MIDI using the method MIDI ratio. And here I've constructed, or I will construct soon, once we have that MIDI ratio intact, a C chord, a C7 chord with our B flat. So middle C being 60, E being 64, G being 67, and 70 being B flat. And we have our array here, and we have our list and also the receiver. So when you see the receiver, the original receiver, that is from the do method. And let's go ahead and add a counter to the mix. So we have our list followed by counter and of course our receiver. And now we're going to go ahead and add our chord. So we are going to be receiving, per se, not quite, 4 values and played simultaneously using our synth, a new synth, the name Varsaw, our Varsaw synth, and our note, which is our argument here, kind of like what you saw with the item before, and converted to MIDI CPS. And I have here for amplitude a bit of randomization where I'm using soft values, but not every note is going to output the same volume, just to give a bit of variance. So you did hear that amplitude variance over there. And randomly choosing inside a function values 40 through 70, maybe every even number, the closest even number, or the closest multiple of 2. We have now 8 iterations of this, of the same Varsaw here, but let's go ahead and have a listen. So pretty cool, not too effective, but you may already see a problem with this. For instance, in our first instance, that receiver, I have 70 here, 3 iterations of 70. And what that simply is the note, in this case B flat, outputted 3 times at different amplitudes. So it might come across as dull or redundant, or maybe even a little too loud for some notes. You can see 68 here, 68 here, 66 here, 64 here. So not that effective, but just to show you that flexibility of randomization and rounding and all of that. So I have a note for myself here, remembering that do returns the receiver and does not store the information to be treated later. And this is where collect will be handy, but looks like I have another set here to explain my point using our do method. So using note and index, we've got a global variable here. So we have this, and all is great because we have envelopes attached to this these numbers and an envelope for our synth def Varsaw. But when you evaluate, remember, when you evaluate X, it's just the receiver, 60, 64, 67, and 70. Now for an alternative, for instance, for sustaining instruments, we do need to add a gate, and this is where do is going to be a little problematic. So I'm adding a gate to my list of arguments and adding an ASR envelope, an attack, sustain with a release, and a little bit of a curve here. Let's see if it will plot just okay. Let's see what that looks like. Yeah, that's a very nice shape with a pretty dynamic slow attack. It's slow, but it looks dynamic to me, and a nice sustain right about there and release here. So what happens is with this is it's going to sustain. until it's called to be released. You can kind of see it as this, where I have attack and sustain and I just hold it there until I trigger the gate, and then the notes will release. So I'm going to go ahead and evaluate that. Oh, let's, you can see, hey, I'm not understanding what this whole thing is. I don't blame you, SuperCollider. Let's go ahead and evaluate it now. And it's our handy dandy synth def. Now, we've got this idea to play the chord again, and this will be X fixed. So I have here our synth def, or our synth in this case, and I want to trigger the gate so they all release. So let's see if that does anything. And it does not. And at the end of this dump of error code, it says mention, or it says message set not understood. So I've got to do a hard command for that and figure what's going on. The message set is not understood, and receiver is 60, 64, 67, and 70. Now, to our understanding, 60, 64, 67, and 70 are the notes, the MIDI notes of that C7 chord. But SuperCollider actually doesn't see it that way. In fact, what SuperCollider is seeing is just a receiver of arbitrary numbers, meaning it's telling me, logically speaking, SuperCollider is telling me, wait a second, I can't release these numbers. These numbers don't mean anything. They're just integers. I think you're asking me to release a set of synths. So notice that our X here, evaluated, is not a set of synths. They're just numbers. So SuperCollider is saying, no, this is, I don't know what you're asking in this way. This is all arbitrary. So I've got a little bit of a code here where we've got this evaluated and this evaluated. So a little redundant on saying, okay, Michelle, I get it. This is the receiver. So what do we do? SuperCollider doesn't see these as notes, so what do we do? Well, this is where collect works. Gate doesn't work with the do method, but it works with the collect method, and I will show you why. So where you have it here, where X is evaluated, and it's 60, I probably should use a different variable for X, but we're just gonna go ahead and run with it. This is returning nil. So pretty much an array of empty slots to be filled. So now that X is evaluated, we've got nil. And what should we fill with that? Well, it's going to be right here. So as you can see with the evaluation here, we've got 4 synths. And now that SuperCollider has recognized that, we can actually set the gate, and SuperCollider will recognize it as, oh, you want me to release these 4 synths. We can evaluate X after that instance and see that they are not nil anymore and they're not arbitrary numbers, but they are synths to be released. So I see it as this. We think of do as something instantaneous to be executed now, but for something that is requiring a bit of sustain, like an instrument that is more of a sustain, or an instrument you want to refer to later in the composition, collect will work. And about releasing all simultaneously without doing it one by one, we can actually use do and have an argument turn off, set that, and have it be the gate. Because now we have it set to where X is the list of synths. And there we go. So this is really the basis of iteration, what it can do, and I think I'm just scratching the surface. I think I'll stop for now, and maybe if I explore things like routine and the fork method and building some pretty comprehensive models, I'll definitely show you in the future. I will say I have seen reverb synths use iteration, and even things like Varsaw, where the phasing can be passed through a function and maybe iterated 10 to 20 times, or something like the harmonic series using iterations. So Eli has touched pretty much that with harmonics and this kind of phase and manipulating his synths there. So go ahead and check out his stuff. And yeah, I'll keep exploring on my end and show you some new tricks there. But until then, happy experimenting and producing the art you love. And thanks always for watching and listening, and I will see you next time.